Hi and welcome to John's Maths book. In this video, we're going to be looking at limits and continuity of a function. If you like the video, then please hit the like button, and I'd be delighted and honored if you'd subscribe to the channel. Without further ado, let's go to the whiteboard. We can say that a function is continuous if we can draw that function without lifting our pen off the paper. Intuitively, the function shown here is continuous as we can draw it without lifting our pen off the paper. If we now look at this function g of x, we can see that it's not continuous or it's discontinuous because we cannot draw it without taking our pen off the paper. As we can see, there's a jump in the function. So for a function to be considered continuous at a point where x is equal to a, the left-hand limit as x approaches a from the left, written as shown here, must equal the right-hand limit as x approaches a from the right. So in this case, both limits must equal f of a. Here we have a function g of x. When x is less than or equal to a, the function is of the form h of x. And when x is greater than or equal to a, it's of the form f of x. This is known as a piecewise function. The limit as x tends to a is equal to h of a. So the limit exists and passes this first test. The limit as x tends towards a is equal to f of a. So this limit also exists. Now for it to be continuous at a, the two limits must be equal. And as we can see, they are not. So we can say that this function g of x is discontinuous at a, as it fails the test of continuity. This is known as a jump discontinuity. Now let's look at this function f of x is equal to x squared minus 1 divided by x minus 1. And let's do some checks to see if we can determine whether it's continuous or not. Just eyeballing it, it appears that we can draw the graph without taking our pen off the paper. Looks, however, can be deceiving. Let's look at the point x equals 1 and see what the limit is. If we just plug 1 into the function, we can see that it's undefined as we have a division by 0. So as you can see, once we've factored it, we can simplify the function to f of x is equal to x plus 1. So the limit does exist and is equal from both left and right. So it passes these two tests for continuity. However, when we look at the value of the function at x is equal to 1, it's undefined and not equal to the limit from the left and the right, as the function has a hole in it at x equals 1. The function can be redefined at x equals 1 and thus removing the hole. This is known as a removable discontinuity. Now let's take a look at this function, f of x is equal to 1 divided by x, and test its continuity at x equals 0. So looking at the left limit, we see that at x equals 0, the function approaches negative infinity. And as x approaches 0 from the right-hand side, we see that the limit approaches positive infinity. Now looking at the value of the function at x equals 0, we see that it's undefined. This function is therefore discontinuous at x equals 0, as it has a vertical asymptote. This is known as an infinite discontinuity.